We'll learn about average value of the function in this lecture. So here's the definition of average of the numbers. This comes from your pre-calculus. Suppose I give you a finite number, say y sub 1, y sub 2, all the way up to y sub n, and I ask you to calculate the average. All you do is add all these numbers and then divide by the number of numbers. Suppose I give you three numbers, say 2, 3, 5. I ask you to find the average of 2, 3, 5. You add these numbers 2, 3, 5 and then divide by the number of numbers. You have three numbers, so you divide by 3. So well, this is the average value definition for any given set of finite numbers. Now, the question is, how do we compute the average temperature during a day if infinitely many temperature readings are possible? So here is a figure where x-axis shows the time t and the y-axis shows the temperature capital T. And the time t is measured in hours, the temperature T is measured in centigrade, degree centigrade. So now we want to guess at the average temperature, which is also known as T average. So in general, when we want to compute the average value of any given function y equal to f of x, this graph is like y equal to f of x, where you have the functional value x lying between a and b, all we do is we divide the interval AB into n equal intervals, and then we calculate the width of each interval, which is b minus a, the rightmost endpoint, minus the leftmost endpoint divided by n. Then we choose subpoints x1 star, x2 star, all the way up to xn sub star in these intervals. Then we calculate the average of numbers, the functional value at the first midpoint x1 star until the functional value of the last midpoint divided by n. So this is one way of calculating average of any given graph with infinite number of points. So if f represents the temperature in this example and say n is 24, this means that we want to take temperature readings every hour and then average them. So this is 24 hours. You calculate the temperature reading for every hour. So here is the formula to calculate the delta x, the width of each interval. Subtract the endpoints, rightmost minus the leftmost endpoint divided by the number of divisions you want to make. And then you also can rewrite the statement for n. It's b minus a divided by delta x. So the average value becomes this formula. In the numerator, you add all the functional values divided by n. We just now calculated n as b minus a divided by delta x. You do some math, take this fraction in the denominator to the numerator. This becomes delta x divided by b minus a. Then you multiply this delta x to every term in the numerator. Your terms looks like this in the square bracket. Then you see the terms carefully. It's all the same type of terms. It's the functional value at a certain x sub value times delta x. So you can generalize this as I, where I goes from 1 to n, which means you have n such points where you calculate the functional values and then multiply by delta x. Now suppose we increase this n value, then we like to compute average value of large number of closely spaced values, and hence we have this limiting condition, and the limiting condition is rewritten in the form of integration. So from here to here, the difference is you increase n. As you increase n, you have infinite number of n, hence this limiting condition, n approaches infinity. Now in the next step, the limiting condition and the summation, both of these are rewritten as integration from a to b. So you remove the limit, you remove the summation, rewrite this concept as integration. So you're summing the values of f of x times dx. Integration means you're summing the values. Now, average value of the function f on the interval ab is finally this formula which we derived, 1 divided by b minus a, the difference of interval, times the integral a to b f of x dx. So this is the average value formula for any given function f of x, where x lies between the two intervals, say a and b. Now, having derived this formula for average value of the function, let's calculate this average value for the given function. So let's write this as our example 1. Find the average value of the function on the interval -1, 2. So rewrite the extreme left point as -1, the right hand point as b, which is 2. Now write the average formula which we derived just now. F average equals 1 divided by difference of these endpoints, right minus left, b minus a, integration a to b, f of x dx. Now plug in the values for b and a, and also do plug in for the function f of x. So here we have 2 negative of -1 integral a to b, so it's -1, 2. The function f of x in the problem is 1 plus x squared times dx. Now let's integrate this. You have x plus x cubed divided by 3. This should be evaluated from -1 to 2, the lower limit and the upper limit. Now simplify this fraction outside this integration. All we have is 1 divided by 3. So evaluate this function from -1 to 2, simplify, and you see that you will get the final answer as 2. So this is the way we calculate average value of any given function on the given interval. The next one, suppose capital T is the temperature, which we already discussed on the top, say at the time small t. Now we wonder if there is a specific time when the temperature is same as the average temperature. So let's try to answer this question using the mean value theorem. So here is the mean value theorem for integrals. If f is a continuous function on any interval ab, then there always exists a number c in the same interval ab such that the value of the function f at c equals f average. We already found a formula for f average from the top, so plug in the formula. F average is 1 divided by b minus a times the integral a to b f of x dx. Now rewrite this a little bit. Calculate integration a to b f of x dx from this. So all you do is, if you want to calculate this particular term, you multiply throughout by b minus a. And hence we have this new formula here, which is the average value of the function. So the mean value theorem for integral is a consequence of mean value theorem of derivatives and the fundamental theorem of calculus. All these are from your Calculus 1. So the geometric representation of the mean value theorem for the integral is given here in terms of positive functions f. All you say is there is a number c such that the rectangle with the base AB and the height f of c has the same area as the region under the curve. Now let's do one more example based on this mean value theorem. So here in this example, the function f of x equal to 1 plus x squared. This is a continuation of our example 1. This function is continuous on the interval -1 to 2. And the mean value theorem for integral says that there is a number c in the same interval such that, let's use the mean value theorem. Let's write the integral value -1 to 2 1 plus x square dx equals f of c times b minus a. This is the formula we calculated for mean value theorem. So the question is, what is the value of c? So let's try to find the c explicit value of c which satisfies this equation on the top. So let's write f average from the top is 2. So we say that f of c equals f average should be also 2. Now we can rewrite 1 plus c square equal to 2, which means when we evaluate c, we get c square equal to 1. So this is a possible value of c. Again simplify, t equal to plus or minus 1 on the interval -1 sorry, -1 to 2. So these are the possible two values for c for which the mean value theorem will be true. Now we have two figures here. Figure 1, where we have the temperature and the time distribution, and we have figure 2 for the mean value theorem. Now combine these two figures and hence we have this figure 3. We see the average value, the curve 1 plus x squared distributed between -1 and 2, and the equal divisions. This is your delta x, which we calculated on the top. So now let's answer one more question. Show that the average velocity of a car over a time interval t sub 1, t sub 2 is the same as the average of its velocities during the trip. So this is a proof problem where you have to show the step to prove the statement. So here is a solution. Let us start by writing, suppose say if s of t is the displacement, if s of t is the displacement of the car, say at time t, then by definition of average velocity, then by the definition of average velocity of the car over the interval, which is t sub 1, t sub 2, is given by delta s divided by delta t. Delta s is the displacement. Distance divided by the time is the velocity. So you write it as increment in the displacement, which is delta s, increment in the time delta t, equals value of the function as the displacement at time t2 minus displacement at time t1. Now you subtract the time values t2 minus t1. Now we write the average value of the velocity function, the average value of velocity function on the interval t sub 1, t sub 2 is given by v average equals 1 divided by t sub 2 minus t sub 1 integral t sub 1, t sub 2, the function what you want to integrate, the velocity function dt. Now this velocity function, let me add a page here. The velocity function can be rewritten as derivative of the distance. So I'm going to rewrite v of t as s prime t dt. The reason is you all understand that here the derivative of the distance ds over dt is the velocity. Now we write 1 divided by t2 minus t sub 1. You are integrating a derivative. When you integrate a derivative term, all you get is just the function back. So after integration, I get s of t. So now s of t is evaluated in the upper limit t2. Negative s of t is evaluated in the lower limit t1. Now rewrite you have st2 minus st1 divided by t2 minus t1. This is the formula for average velocity, where you subtract the distance at 2 points t1, t2 divided by the difference in the times. So let's get back to the question. We were asked to show that the average velocity of a car over a time interval t1, t2 is same as the average velocity of its average of its velocities during the trip, where we have shown that it's the same formula. We have derived one formula on the top and again one more average velocity formula here. So in this lecture, we learned about finding average value of a function using this average formula, which we derived here in the starting of this lecture. That's this one. F average is 1 divided by b minus a integral a to b f of x dx. So give a lot of importance for this and learn this formula to find the average value of a function on any interval ab. Now we end this lecture here.